This is the screencast for section 3.3, example 8. Looking at graphs of logarithmic functions. Now, first of all, y equals natural log of x was one of your, y equals log of x was one of your basic functions. We've talked a lot about how it has a vertical asymptote here at x equals 0. It comes through the x-axis and continues then up to infinity. Now, since we're exploring logs and exponential functions, we know that since they are inverses of each other, they're actually just a reflection over the line y equals x. So y equals e to the x has a reflection over the line y equals x. Its inverse is y equals natural log of x. Y equals 10 to the x is going to grow a lot faster than y equals 2.7 to the x. A higher base is going to grow a lot faster. So then the log function will be skewed as a reflection of that faster growing exponential function. So the base of the log will skew the function similar to how the base of an exponent will skew the function. Well, let's look at a few logarithmic functions and how to transform their graphs. So part A, the directions say describe how to transform the graph of y equals natural log of x or y equals log of x into the graph of the given function. Well, g of x, that is natural log of x plus 2. That means there is going to be, let's see, a horizontal shift left 2. If I wanted to draw a sketch of that function, I could say that instead of the vertical asymptote at x equals 0, the vertical asymptote is now going to be at -2. And then also instead of the y-intercept at 1, because the log of 1 is 0, remember log of 1 is always 0 because what exponent of something gets you 1? 0 does. Anyway, instead of the x-intercept being 1, 0, it's now going to be shifted left to -1, 0. So I can draw a sketch. As a matter of fact, you can see this graph actually crosses through the y-axis. Now wait a second. I thought you said you couldn't take the log of 0, because wouldn't this point be 0, something? Well, the difference is this is the natural log of 0 plus 2. The natural log of 2 is something really messy. Natural log of 2. So the y-intercept is going to be 2, 0.69. So I've got a pretty accurate graph of this translated sketch. Part B, h of x equals the natural log of 3 minus x. Uh-oh, here we go. We've got two transformations that are horizontal. Pay attention. You have to first rewrite h of x as, let's see, the natural log of, now I want the x term first, trust me on this one, so I'm going to put -x plus 3. Now I'm going to take the natural log and I'm going to factor out the negative. So I have -x minus 3. Now I can actually see my transformations and interpret them as we have been over chapter 1. First, this is a horizontal reflection over the y-axis. Then we have a horizontal shift right 3. Remember, we are plugging in numbers to horizontal functions, so anything that interacts with the input is going to create an opposite reaction that you would think it does. So we are not going to work in order of operations for these transformations. We're actually going to work in opposite order of operations. We need to do the reflection first and then the shift right 3. So this guy is going to look like, instead of coming up this way, we're going to come down this way and go right 3. So let's see. Instead of the x-intercept at -1, it's going to go 0, 1, 2. Instead of the vertical asymptote at x equals 0, it's going to be at x equals 3. The y-intercept, so the natural log of -0 plus 3, so the natural log of 3 1.10. So this graph is going to look something like this. Well, that wasn't wonderful, but close. Part C, g of x equals 3 times the log of x. Well, that one's not too bad, actually. I've got, let's see, a vertical stretch by 3. So nothing's going to change as far as the x-intercept is concerned or the vertical asymptote. The only thing this is going to do is stretch up higher than the original log of x did. There's no real good way to show that with a sketch, but that's why I made sure to describe my transformation accurately. Now part D, that's got a vertical shift up 1. Remember that 1 is also can be written at the end, so this could be log of x plus 1. Vertical shift up 1. So if I wanted to sketch that graph, instead of 1, 0, I've got 1, 1. The vertical asymptote isn't going to change at all, so I just have to come up that way through the x-axis. Oh, so now, interesting. If I wanted to solve for what makes the function cross through the x-axis, I got to find out when y equals 0. So I could do 0 equals 1 plus the log of x. So I subtract 1. So negative 1 equals the log of x. What exponent of 10, so now I need to change this to exponential function like we did before, and I get 10 to the negative 1 equals x, so that would be 1/10. So this would be 1/10, 0, and this would be 1, 1. The now try problem for example 8 is number 41. F of x equals the natural log of x plus 3. So now these instructions actually tell us to do all the work I was doing in the last ones. That's why I decided to do a little bit extra. Describe how to transform the graph of y equals natural log of x into the graph of the given function. Sketch the graph by hand and support your sketch with the grapher. So now we actually have to use the graphing calculator to make sure our graph is correct. Well, I see that f of x equals the natural log of x plus 3. Basic function is y equals natural log of x. The only thing that's changing is we're adding 3 to the input, which is going to create a horizontal shift left 3. So instead of a vertical asymptote at x equals 0, I have a vertical asymptote at x equals negative 3. Instead of the x-intercept at 1, 0, I'm going to move it 3 left. 1, 2, 3. So it's at negative 2, 0. Now I can see that my graph is actually going to go through the y-axis this time. So I can find the x-intercept by plugging in, or the y-intercept, by plugging in 0 for x. So the natural log of 3 by my calculator, oh, I already calculated that, look at that, is 1.10. So this will be 0, 1.10 approximately. So now I'm going to check that graph. I'm going to zoom 4 because I can tell that all my stuff is pretty close there. Looks good. I've got a vertical asymptote at x equals negative 3. I've got, let's see, trace. Let's hit negative 2. Make sure, no, negative 2. Negative 2, 0 is a point on my graph. That's good. And let's also make sure the x-intercept or y-intercept is right. Yep, there it is.